Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 810, Nonlinear Systems. So we're going to be solving by graphing and algebraically. So if we're solving the system of equations, we're going to solve the equations by graphing. So we're going to start by graphing the quadratic function. The vertex of this quadratic function, this one is in vertex form. So your vertex is always the opposite of what's in here, comma this, right? Because this is your left, right, opposite of what you think, up and down. So instead of it being at 0, 0, it's at 2, 32. Describe the transformation of the parent quadratic function that produces the graph of g of x. So we know that we're shifted in the positive direction, right 2, up 32, we're reflected down, right, reflected over the x-axis, and vertically stretched by a factor of 2. Okay? To make the graph more accurate, plot the points where the x-intercepts occur. The x-intercepts are the solutions of the equation. So we're going to set it equal to 0 and solve. When we set this equal to 0 and solve, we're going to get negative 32 over here because we subtract 32 from both sides. We divide by negative 2 on both sides. Negative 32 divided by negative 2 is 16. We take the square root, positive negative square root on both sides. We get positive negative 4. We add 2 to both sides. Negative 2 plus 4 is, so we have negative 2 plus or minus 4. So negative 2 plus 4 is 2. And negative 2 minus 4 is negative 6. So we have 2 and negative 6. So 2, 0, negative 1, 2, 3, 4, 5, 6. Okay. Our vertex was 2, 32. What did I do wrong? Should be 6, 0, and negative 2, 0. Did I miss a sign somewhere? Oh, this is plus 2 to both sides. This is positive 2. My bad. So that should be positive 6, and that should be 2 minus 4 is negative 2. Because I was like, this does not make sense. Do you guys understand why this didn't make sense? If my vertex was at 2, how could my x-intercepts been 2 and negative 6? It didn't make any sense at all. So it should have been negative 2 and positive 6. And now that has that nice mirroring over my axis of symmetry. I knew something was up. And it was because I didn't realize that that hadn't been moved already. That should have been positive 2. Okay, so you need to kind of look and figure out why it's not giving you that symmetry. There has to be some error. All right, so then my vertex was 2, 32. And we know that it's going down. Going down. Young timber. All right. Use these points on the vertex to draw the graph. Now graph the linear function. The y-intercept is blank and the slope is what? So our linear one is y equals negative 8x plus 48. So with our negative 8x plus 48, our y-intercept is 48. So we're going 4, 8, 12, 16, right? We're trying to get to 48, so we're going by 4s, 40, 44, 48. We're going down 8, down 4, down 8, over 1, 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 and so on. So we're going to connect this equation. All right. So the y-intercept was positive 48. Your slope was negative 8. Right, this is your slope. This is your y-intercept. Y equals mx plus b. The line and the parabola intersect at 2 points. Identify the coordinates of those points. We have 2, 32 and 6, 0. Right? Those are the solutions of the equation, points that work for both equations. Solve the system of equations algebraically. So if we were going to solve these algebraically, they're both set equal to y, so we can substitute them in for each other, right? Substitute a whole side for a whole side. This can go in here, right? Because if y equals that and that equals y, then they equal each other. So when we do that, we can go like this. Oh, actually, I should probably square this first, huh? So square that first, because parentheses, exponents, multiplication or division from left to right, addition or subtraction from left to right. So x minus 2 squared is x minus 2 times x minus 2, x squared minus 2x, so x squared minus 4x plus 2, plus 32. Now I can distribute. So I'm going to have negative 2x squared plus 8x minus 4, right? I have negative 2x squared minus 8x minus 4 plus 32. How did they get a 48? Oh, because what they're doing is, okay, I see what they're doing. What are they doing? Simplify the right side. Okay, there you go. Add 8x plus 48 to both sides. So they're saying add this to both sides, okay. So if I add negative 2x plus 8x minus 8x plus 8x, those cancel each other out. Right here I had 32 minus 4, so that was, what is that, plus 28. So 28 minus 48. What is 28 minus 48? Negative 20. Bring down my negative 2x squared. Okay. Pull out a negative 2. Negative 2 times x squared. Oh, they're factoring already? Hold on. Negative 2 times x squared plus 10. It's really confusing me with their work, in all honesty. I'm so confused with their work, the way that they're doing the work. I'm doing it off to the side because it's bothering me. All right, so negative 8x plus 48 equals 2 times x minus 2 squared plus 32. I'm just going to do my work separate because, like, their organization is bothering the heck out of me. So this is how I would do it. X minus 2 squared is x squared minus 4x plus 2, and I have it times 2 plus 32 equals this. 2x squared minus 8x plus 4 plus 32 equals this. They're combining too many steps and it's making my brain hurt. So this is going to be 4, 5, 6, 36. Now add 8x to both sides and they're gone. Now you have 48 equals 2x squared plus 36. Minus 48. 2x squared minus, what is 36 minus 48? Negative 12. Two times x squared minus 6. What is x squared minus 6 going to give me? So I'm going to have 2 equals 0. That does nothing. X squared minus 6 equals 0. X squared equals 6. Square root, positive, negative, square root of 6. You're going to make fun of me. What did I do wrong? From the very beginning, I've been screwing something up. Do you guys see my problem? You see what the problem I wrote? You see the problem that it started with? You see there's a negative in front of that too? You see how that changes everything? If I have a negative here, then this becomes negative, positive, negative. 32 minus 4, 28. When I added 8, I'd have 16. I had plus 28, so 28 minus 48. It's just from there down that got messed up. When you copy a problem over, make sure you copy it correctly or it's going to give you a headache. Because when you go to plug back in, it's not going to work. So you had, that's still negative, right? Negative 2x squared plus 16x minus 20. Yeah, what's up? Yeah. It's supposed to be minus 24. This was a 24. Okay. Now I'm good. So now that I actually have the right equation, since I, had screwed it up before. Sorry about that. So now that I'm here, what can I do? I can pull out a negative 2, and I'd have x squared minus 8x plus 12. 1 and 12, 2 and 6, 3 and 4. What multiplies to positive 12 and adds to negative 8, negative 6 and negative 2. Negative 2 times x minus 2 times x minus 6. Set that equal to 0, nothing. Set that equal to 0, you get 2. Set that equal to 0, you get 6. So my answers are 2 and 6. So if those are my x values, I have to plug back in to get to my y's. So I go back up here and I plug in a 2 to either equation. Negative 8 times 2 plus 48. Negative 16 plus 48 is going to give me what? 32. Negative 8 times 6 plus 48. Negative 48 plus 48 is 0. So my solutions are 2, 32 and 6, 0. Let's go back. 2, 32 and 6, 0. 2, 32, 6, 0. It works. All right. Let's do one. I hate doing in there like setups because they just make my head spin. But if we were going to do this by graphing, so it says the previous example, the graph the quadratic function is shown below. Graph each linear function below on the same coordinate as the parabola. So if I'm graphing this, I have negative 11, 4, 6, 8, 10, negative 11, up to 1, 2, over 1. So here's one line. That's your g of x. Plus 14. Down 2 over 1. Down 2 over 1. Be aware that the y-axis is going by 2s, but the x-axis is going by 1s. That gets confusing. How many points do the parabola and line 1 intersect? So, and your g of x? They intersect at 1 point. How many solutions are there for the system consisting of the quadratic formula in the first? 1 solution. How many points of the parabola on line 2 intersect? 0. How many solutions? 0. A system of equations consisting of 1 quadratic equation and 1 linear equation can have 0, 1, or 2 solutions, right? It could either intersect in 1 place, it could go through at 2 places, or it could not go through at all. How many solutions does the following system of equations have? Explain your reasoning. So you can either graph it or you can do it algebraically. So algebraically, plus x minus 1, 0 equals negative x squared plus 11x minus 28. Take out that negative first. One and 28, 2 and 14. Does 3 go in? No. 4. 5, no. 6, no. Back to 7. What multiplies to positive 28 and adds to negative 11? Negative 7, negative 4. Negative x minus 4 times x minus 7. So your solutions are 4 and 7 for your x's. You have to plug back in to get your y. Negative 4 plus 1 is negative 3. Negative 7 plus 1 is negative 6. So you're going to have 4 comma negative 3 and 7 comma negative 6 as your 2 points. Let's double check that they work up here. 4 squared is 16. You'd have negative 16 plus 40 minus 27. 16 negative plus 40 minus 27 equals negative 3. So that checks out. Let's try the 7. Negative 49 plus 70 minus 27, and you get the negative 6 that you're supposed to get. So it works for both equations, and you know that you didn't mess anything up. So these are the 2 solutions. It has 2 solutions. Does that make sense, guys? Set them equal to each other. Get everything to the one side, set it equal to 0, and I factored. So here, negative 2 equals negative x squared plus 10x minus 27. Add 2 to both sides. Negative x squared plus 10x minus 25 equals 0. Take out the negative. X squared minus 10x plus 25. Okay, let's factor this. So we'd have 1 and 25, 5 and 5. What multiplies to 25 and adds to negative 10? The negative 5's. Negative x minus 5 times x minus 5. So my solutions are 5, right? 5 mult 2 because it happens twice, but we really only have one solution. So it's 5 comma something. So 1 solution. And if we wanted to know what it is, we plug it in. 5 squared is 25. So you'd have negative 25 plus 50 minus 27. 25 negative plus 50 minus 27. We're going to get negative 2. Does that make sense? Yes, because this line only contains y values of negative 2. So, some practice problems. Negative 2 equals x squared minus 2. We can add 2 to both sides. And we get 0 equals x squared. Square root both sides. X is 0. So 0, if x is 0, what is my y going to be? It's going to be negative 2. Well, let's double check. 0, negative 2? Yep. So I have one solution, and that solution is at 0, negative 2. x equals x minus 3 squared, which is x squared minus 6x plus 9, right? If I do x minus 3 times x minus 3 and FOIL it out, minus x squared minus 7x plus 9 equals 0. 1 times 9, 3 times 3. Am I ever going to get to the negative 7 by factoring? No. So what do I have to use? Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I have 49 minus 4 times 9, so I get 13. So I have the square root of 13 plus or minus 7 all over 2. All right, round to the nearest tenth. So 13 square root plus 7 equals, divide by 2 equals, I got 5.30, 10, 5.3. They wanted only the one decimal place. And my next one, 13 square root minus plus 7 equals, divide by 2 equals 1.7. So I got 1.7 and 5.3. All right, and then if they wanted you to actually solve for the points, so y equals x. So that means that my coordinates are going to be 5.3 comma 5.3 and 1.7 comma 1.7, right? Because your x and y are the same. So those are the coordinates. Is this making some kind of sense, guys? Hopefully, a little bit. All right, so let's skip down to these. Graph the system of equations. The graph of the system of equations is shown. State how many solutions they have, then estimate the solutions. Okay, how many solutions? How many solutions, guys? 1, 2. And what are they? They're approximately maybe a half comma negative 11. And maybe like 6.25 comma 16. Negative. Something like that, right? How many solutions? 1 solution. And I would say it's approximately 1 comma 4. Estimate the solutions to the system of equations graphically. Confirm the solutions by substituting the values into the equations. All right, so y equals x squared, we know that one. That's that parent function, right? We have 0, 0, 1 squared is 1, 2 squared is 1, 2, 3, 4. Mirror it. Y equals 1. My solutions are 1, 1, and negative 1, 1. We have 2 solutions. We plug back in to check. 1 squared is 1. Negative 1 squared is 1. We know that it works. The next one, this is our parent function shifted down 1. So instead of 0, 0, we're at 0, negative 1. Over 1 up 1. Over 1 up 1. Over 2 up 1, 2, 3, 4. Over 2 up 1, 2, 3, 4. So here's our graph of the first thing. And the next one, this is the same thing as 1/2 x minus 3. So we start at negative 3, negative 1, negative 2, negative 3. And we go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. So what do you guys think for number 10? How many solutions? No real solutions. Okay, so we have 14. So we go by 2s. 2, 4, 6, 8, 10, 12, 14. Down 1 over 1, 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 right? Your slope is -1. Your y-intercept is 14. This one's downward parabola. Looks annoying. Let's do the vertex. -b over 2a. -15 over 2 times -16. -15 over -32. 0.46. So like about a half. We'll go by ones. Plug back in. I'm going to store that in 1. Okay. So that times 15 plus 10 plus parentheses, recall 1 squared times 16 negative equals, all right, so I got 13.5. 2, 4, 6, 8, 10, 12, 13.5, so somewhere around here. And we know it's going down. We can plug in a 0 to get the x-intercept. We get 10. 2, 4, 6, 8, 10. Mirror it. How many solutions? One, right? And it's at -0.5. They said the approximate solution, estimate it, so it's about -0.5. It was like, what was 15 divided by 32? It was 0.468, approximately 0.5. And then what's this height? 13.5. Is this making sense to you guys? Yes? All right, so your homework tonight is page 485 and page 486. I hope you guys enjoyed this lesson on 810, nonlinear systems. Please like and subscribe and have a fantastic